If you're a developer who wants to get into the growing field of robotics, what skills should you have? What languages should you know? Well, we're going to talk to someone who can help us answer those questions on this episode of Dynamic Developer. Robots come in all shapes and sizes, but typically they're autonomous devices that operate on their own to help us complete a task. What if you were actually building a robot that was a distributed computing platform? And what if that robot looked like a dog? And what if you're a developer who wants to write code for that robotic distributed computing dog? Well, on this episode of Dynamic Developer, I'm joined by John Suit, advising CTO of Koda, who's doing just that. John, thanks for being here.
Thanks for having me.
So let's talk robotics. We've seen a lot of developments recently in 2020. We have the Boston Dynamics news around Hyundai looking to acquire them. And then on the positive side of things, sort of a recognition that robotics is really taking off. And then on the flip side of that, you have some announcements in November 2020 around Walmart sort of ending one of its partnerships with Bossa Nova Robotics. So it seems like there's a lot happening in the field of robotics right now. From your take, what can we expect to see in the field in 2021 and then beyond?
So I agree. There's a lot going on in robotics. My background is actually in cybersecurity for the last 20, 25 years, but also in decentralized artificial intelligence and, big information analytics systems, which becomes really, really important to robotics. And so when I was approached by Koda to take a look at their, super cool robotic dog, it became pretty apparent that the things I was interested in were the things that you'll need on a robotic platform if that platform is going to interact with people and it's going to learn. So one of the first things I had asked, and a buddy of mine's one of Coda's co-founders, he said, "Hey John, you got to take a look at this." He and I had worked together in several different companies, and he kind of knows what I like and what I don't what I choose to work with or what I don't. And he said, "You got to see this dog. First instantly I thought of the YouTube robotic dog Boston Dynamics video." And so I asked him right off the bat, I said, like, does it have a head? Because
It's not that creepy looking, is it?
yeah, I mean, I instantly had visions of this, militarized, robotic dog thing. And when he said, no, 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 no. So he sent me a picture of it. And it's this metallic blue, like very cute looking, but very capable robotic dog. And and I said, well, what are you going to use these for? Like, what's the application? And he told me the first application that they're going to use them for are visually impaired kids, to help not just learn from real, organic dogs, but to help learn the environment. And these are true learning systems. So I think what you're going to see in 2021 is not just the advancements in motors for a walking robot's gait, which is one of the hardest things to accomplish, for a robotic anything. You're going to see a variety of sensors that are coming into play, which weren't available. Think about like the camera array that's on your Roomba, vacuum cleaner is VSLAM. It's pretty advanced. And then you have LiDAR systems, that are very good at depth and very good at, building an array of image for something. All these things, all these sensors, audio sensors, directional sensors come into play when you're talking about robots. And to put all that together and actually, do something with it, you're talking now decentralized artificial intelligence. You have to have a, kind of a decentralized file system to deal with that. And, blockchain has made great advancements in that area. I think a lot of people, they hear blockchain, they think digital currency. That's true. But it's also a great way for a lot of things that are all learning something to report in to a general ledger so they can share information in order to all learn something, how to do something. So if I had let's say I had a Koda that was in New York City, and it was helping a visually impaired kid navigate the streets and stop at, intersections and things like that, and understand, when a siren goes, it understands the direction of, say, an ambulance that's coming and knows to stop on the curb instead of that kind of stuff. When a Koda in Aspen learns how to walk in the snow, and then that Koda that was in New York goes on vacation to somewhere where there's snow, for example, they'll have that knowledge because the other Koda learned it. That's the kind of thing where, that I think is particularly cool.
I'd love to drill down on that a little bit and kind of talk about those technologies that are making robotics really sort of possible in ways that we didn't think about, just even a decade ago. Because I think most people think about, okay, we've got automation, we've had that in factories for decades. We understand that. We understand how robotics maybe can work in, say, warehouses and distribution. We understand how robotics works in drones. And I think a lot of people also understand how there may be a client-server relationship between a robot and the cloud. But there's still this concept that you talked about of distributed computing and being able to do processing on the devices and then not just share that information up to a central location, but actually to have processing done on the devices that then is shared sort of with other devices. And that's actually part of the overall system is kind of new, at least in the robotics field.
Yeah, the whole concept of decentralized artificial intelligence, gives you the benefit of learning something that the rest of the devices or peer devices may not have the opportunity to learn, simply because they may not have the terrain or they may not have a particular circumstance, just like people. So, one of the things you have to do right off the bat to deal with this stuff is obviously you have security. You have to give permission what to share, what not to share. You have to have infrastructure, data in motion, data at rest, all that needs to be taken care of. Once you have that all figured out, though, it really opens up the advantage of what you're saying is I can now, not just share things that I learned, but I can learn things differently, even in similar environments, because of this concept called ephemeral memory. So if you can get any robotics to this level where they learn something and then I force them to forget and to learn it again, then if you keep doing that, you end up with many different ways to solve a problem. You find out the optimal way to solve a problem for any given condition, which is very similar to how we work. So that's the idea. You have a robot, in this case that I got interested in, a robot dog, that once it learns how to climb stairs, I wanted to forget how to climb stairs because I wanted to try. I wanted to reason another way, and I wanted to reason another way again, and then again, and then what you get is a better and better robot dog over time. And then when the dog gets to a point where it can share that information of all this aggregate learning, to other dogs, you have this refined knowledge at that point. Maybe not wisdom yet, but you definitely have knowledge that it can share. And so that happens because of, the ability to reason on the device, the ability, not just, everybody thinks of like rules engines and inference engines, but there's true reasoning that can take place. And it happens because of the variety of sensors. It happens, and obviously there's many GPUs, there's lots of memory, there's a lot of processing power on these devices and on these robots, but it's having the availability of what's happening in the real world being brought in by the sensors, and in some cases more than we have. We look at we hear and see and feel a very narrow bandwidth of the energy around us. They have a little bit higher aperture, in some cases, they have more information, in some cases they have less, but it's the ability for them to take that information and mesh it and reason and all that you ultimately get something that can really work well in in multiple different environments.
How critical is that to the development of robotics in general? I mean, robotics need to be able to serve a specific purpose. And we think about, I think when you say robot to person, they think of the sci-fi version that we've seen for generations of some type of, going back to sort of automatons. And we think of a general purpose robot that looks humanoid in shape and kind of can do everything. And that doesn't seem to be the way, although there have been some advances in robots that do look that way, but it seems to be that we're having success with robots that are maybe more specialized in what they look and the functions that they do. Where do you see, I guess, those, that going, right? Where do you see, how specialized do you see robots being? Like Koda, is a dog. It looks like a dog. It functions like a dog, but you're talking about a purpose that isn't just for a pet, right? So we've all seen the toys that are, you would call kind of toys that are, dogs, or that are designed to sort of be entertainment. But this, what you're talking about is a much higher level use and the role for this device to play.
Yeah, you're right. It is a very high-end computing platform. And it's not just a computing platform, it's a very high-end reasoning engine. So, to the point where, you can get, let's say, you have a Coda and it needs to recharge, and you want it to mine for digital currency. That's the kind of processing power we're talking about. So it literally makes money for you while why it recharges and sleeps. That it's that level we're talking about, and it's a good point. Purpose-built robotics, or even purpose-built IoT devices. I mean, there's huge advancements in IoT. Just recently, and look at what happened at MIT with their MCU net. They figured out a way, because you have such limited resources on IoT devices, and they figured out a way to optimize the engine, basically the search space, and optimize the engine so that you're not hindered by that limited availability, because algorithmically it can adjust to whatever it has available at that moment in time. And I think what they will figure out, maybe they've already figured out, I don't want to take anything away from them, is that they're going to ultimately be able to do that dynamically. It's what they at least what's available that they figured out is, now they don't have to tailor it for every platform, which is amazing. But I think they're also going to then very quickly figure out, now they can adjust their algorithms dynamically as resources become available or no longer available, and so it can tune itself on the fly. And that's when you can start to mesh IoT devices, and you get all this stuff, and all that kind of stuff. So to your point, yeah, I think you'll see some robots that are specialized, but I also think you're going to see robots that can do a lot of different stuff and can work together.
And do you think is that only possible through some type of distributed computing, the AI, an AI driven system, which just wasn't possible in the past? I think back to the first Roomba I had that used basically, bug logic, right? In terms of like, turn this much, go till you hit a wall, turn this much. It was amazing what you can accomplish at the time with some just rules-based algorithms, right? But it seems like, in order to progress to the next level, that's not going to be enough. There's only so much you can do with those simple kind of, that simple code. You need an AI approach that you're describing to really step to the next level.
Correct. You really do. And you also need a data transfer platform. IPFS and a planetary file system is perfect for that. So this gives you the ability to move data around, and do it in a way that doesn't have to be necessarily directed, from any particular source or destination. Think of it as kind of a meshed, storage array for the planet. I didn't name it, but it's, it sounds sci-fi, in a planetary file system. But it really is that. You can host pretty much anything on it, and you don't have to be specific about where you store data. And so it's that kind of thing which will really, I think, launch, the more devices that take advantage of things like that, you get, instead of kind of getting this stair step approach to things, you're gonna get this, it's pretty exciting.
So let's talk about getting into the field of robotics. So if you're watching or listening to the show right now and you're in IT, you're a developer, and you're thinking about robotics as a career path, or hey, this is something that I see taking off, that I want to get into, what are the skills that companies like Koda and other robotics companies are looking for, that people should be developing to really find a place within the industry?
Yeah, specifically, on there's the physical side, and there's the instructional computing side. Obviously, people that came out of semantic web, people who came out of ontological systems, understanding the big data lake AI stuff as well, but really understanding kind of discrete reasoning engines and discrete inference engines are always a plus. But I will say, right off the bat, C and C++ still rules the roost, especially on devices that have limited resources. That's not necessarily Coda because it has a lot of resources, but for the smaller IoT type devices, you need to be efficient. And we kind of do this thing where we are ultra efficient with memory, we're ultra efficient with storage, and then we get all this storage and memory available to us, and so we can abstract languages and things like that, and then we miniaturize, and it goes back and forth, and now we're back and we're looking for C and C++ guys all the time, and with the people I'm talking to. So it's important.
So beyond kind of the miniaturization and being able to work within limited resources, what is unique about building software, building the systems for robots like Coda?
I think one of the things that no one talks about, but it's close to me, because I've been in this space for a long time, is people who understand and get security. A lot of it is, how do I build it? How do I get it to work? That's all great, but if people are fearful of what you're building, you need to address that right from the ground up. You need to understand what data can be shared, what can't be shared. You need to understand data at rest. You need to understand, data in transit and data in motion protection. It's all that stuff, and understanding it from the ground up and getting it is a really important skill to have. There's a lot of people who've jumped into cybersecurity in the last 10, 15 years, but not so many people who actually kind of lived and breathed when everything was open and a problem and things like that. And in IoT and in robotics, it is like that. And you need to be aware of how things can be exploited. And so I think that's a great skill to bring to the robotics industry, and something that's sought after, is not just being able to make something function or be efficient or optimized. It's making sure that it's secure enough that people will actually consume it and will want to use it. And you're not fearful of utilizing the technology, and that's huge, because we have 100 years of sci-fi to overcome when it comes to robotics.
Yeah, everybody has the image of either the helpful or the evil robot, right? There's not really a lot in between. I mean, we've talked about DevOps for a very long time, and not too long ago, DevSecOps really became sort of a watchword. And I've done some work with David Rumley from Carnegie Mellon and For All Secure around that. And, how important, and he talks about that in an interview that he and I did around, making sure that that's sort of ingrained in every aspect of the production process, from the very beginning to the middle and deployment to the after act, is bringing everything full circle. How do you manage that with a product as closely integrated to people and the consumers as a robot dog? I think about, we all have cameras in our homes these days in some respect. You and I both have one on the devices we're talking on. We have microphones with smart speakers everywhere. We have smart thermostats. We have smart security systems. We've seen some issues with data privacy around IoT devices. But to me, something like Coda, with the array of sensors that it has and the interaction that it's going to have with its customers, is even maybe next level above that, I guess. And also when you think about the distributed nature of the system. So it's not just, hey, I'm talking with my device is communicating, waiting for a watchword on the smart speaker to talk to Amazon's, Google's, whoever's servers, and then provide the response back down. But maybe it's talking to the Koda next door, or maybe it's talking to other, or maybe that information is being shared not just up and back in a one way, but it's really being shared up, back, down. How do you manage? How do you manage that?
Well, obviously, from the ground up, you have to have the most state of the art, security available in terms of data protection and data in transit. But also, there were simpler things. The first thing I asked when I was introduced to this, whole concept of a, robotic dog was, does it have a physical on-off switch? That was the first question I asked, because it's just how I think, and it does. And so I said, okay, that's a good first step. I want to know you can turn this thing off and it will get turned off. It's more ground up than checking boxes. I don't for me, I don't need a compliant with security, robotic device or IoT device. I need an actual, security well thought out device. That's the most important thing. So you're right. If I have a variety of sensors and they're listening and processing and all that, I need to be able to define how those are used and how that data is moved and where it is stored and all that stuff. And so that's configuration. That's what a user is willing. Obviously, there's defaults, and obviously there's different levels of acceptability depending on what you want it to do. But you get to decide that. You get to say, this is what I'm okay with. This is what I'm not. On the most shareable setting, your Coda may learn faster, but you may not care about that. You may care more about not sharing information. So it really is what you're tolerant of. But it's definitely the most important thing is to be thinking about this, when you start, not thinking about it as an afterthought, because that always happens.
Do you think that most developers are thinking about security enough, or do you think that there's still, I mean, there's always work to be done somewhere. You can always improve. So I don't want to say that, hey, we've reached the pinnacle and there we are, because I don't think that's ever realistic with anything.
I think software engineers want to solve problems. And if the problem is, for my camera to be able to identify movement and be concerned about battery storage, or sorry, battery life and things like that, I think a software engineer will want to solve that problem. The software engineer has to be told part of the problem is security. They have it. That has to be part of, like, you don't win, to a software engineer, I won when I solved the problem. Well, they need to understand they don't win until you solved it in a secure way. And I think if you instrument and instantiate that into your development process, then one, it's a very gratifying win, as a software developer. But it's one that you're not going to get, it's not going to come back that the thing you did caused all these problems. There's a couple of software companies out there today, that are probably not proud of where they came from. And then that's unfortunate, because a lot of people do a lot of hard work. If from day one you were instructed to make sure that I don't want to go into specifics, but right from day one, part of you solving a problem is you solving a problem that securely handled everything it needed to. I think that's where you win. And I think that needs to be instilled in the culture, not just for robotics. I mean, obviously it's for everything, but it is important for robotics, especially because these things move, and they see and they listen and they interact. IoT devices, it's also just same problem for all the same reasons you said. So I think culturally, if we thought more about how to solve problems, with these things in mind as part of the answer, I think we'll go a long way. People are starting to figure this out, by the way. I'm not, this isn't a revelation on my part. People are figuring it out. I will say 20 years ago, not many people outside of, the intelligence community and, other very kind of, people working in hostile environments were thinking about this stuff. But certainly at least is on the, front and center for a lot of companies that are, kind of already had their CEOs on the front of newspapers.
And that's what no engineer wants to have their work and their code be the reason that the CEO has to issue an apology. So let's talk a little bit. Let's wrap things up. When can we expect Koda to hit the market? I know I think it's out as sort of as a prototype, and you have a pre-production kind of models available. So when are you all actually going to release it as something that folks can actually buy?
We are going to announce something very soon.
Okay.
No one has told me I can say when it is, so I'm not going to do that. I'll maintain that level of security. I mean, they're going to be very cool, and they are high-end devices. So, we're not planning on a mass launch of anything. They'll become available. It'll be like you'll hear of somebody who has one, maybe, kind of thing. And the reason is this really is a platform for decentralized AI. And we want to innovate decentralized AI just as fast, if not faster, than the robotics platform. So if that means we don't sell as many Kodas off the bat, so be it. If it means we get to sell a lot more Kodas later with a lot better decentralized AI, that's the idea, to get them out there. But they will be available.
How important is it to have or I guess that sounds to me very similar to other companies that have tried to sort of reshape sort of markets, who release a product that is, high end, to early adopters, and then they plan to iterate with software. I mean, that works a lot of times. I could think of one, company very, that's worked very well for.
It has.
And so that's kind of what I hear you kind of describing. And is that important when you do have a device that is so, because I imagine, I haven't seen pricing yet on the devices, but I imagine given the computing power, we're not talking about a $29.95 toy dog that you buy, in your favorite sort of big box toy retailer. This is a serious device. And so it's important when you're making that kind of investment that it is able to adapt and to grow and to be around for a while with you. Am I correct?
Yeah, absolutely. That's entirely correct.
Well, I know now that we've done this video, that who to ask when I want to get on the waiting list for these things. But John, thank you very much. I really appreciate you taking the time.
You got it.
And thank you to all our viewers and listeners for joining us as well. You can listen to more episodes of Dynamic Developer on your favorite podcast platform, or read a transcript and watch a video at TechRepublic.